Welcome to an introduction to Thevenin's equivalent circuit and Thevenin's theorem, narrated by Alan Maddock. What can we learn about Thevenin's equivalent theorem and Thevenin's equivalent circuit? What is Thevenin's theorem? Who came up with Thevenin's theorem? Why was Thevenin's theorem needed? How does it work? What is Thevenin's equivalent circuit, and what does all this mean? What is Thevenin's equivalent circuit? It all starts with Thevenin's theorem. This is the combination of batteries and resistance with two terminals can be replaced by a single voltage source E and a single series resistor R. The value of E is the open circuit voltage of the terminals, and the value of R is E divided by the current with the terminal short circuit, as seen over here in the image to the right. Who came up with this theorem? This theorem was independently derived in 1883 by Leon Charles Thevenin. As a result of studying Kirchhoff's circuits law and Ohm's law, he developed his famous theorem, Thevenin's theorem. This made it possible to calculate more complex electrical circuits and allowed people to reduce complex circuits into simpler circuits called Thevenin's equivalent circuits. Why was this theorem needed? It is a very simple question that many new to the subject or concepts might ponder. Why am I learning this? Thevenin's theorem is especially useful in analyzing power systems and other circuits where one particular resistor in the circuit, called the load resistor, is subject to change. And recalculations of the circuit is necessary with each trial value of load resistance to determine voltages across it and current through it. How does it work? What is Thevenin's equivalent circuit? Thevenin's equivalent circuit. Let's suppose that we decide to designate R, in the example above, as the load resistance in the circuit. We already have multiple ways to analyze the voltages across R and currents through R, but this takes time with those methods and could potentially involve a lot of work. Thevenin's theorem makes this easy by temporarily removing the load resistance from the original circuit and reducing what's left to the equivalent circuit composed of a single voltage source and series resistance. The load resistance can then be reconnected, Thevenin's equivalent circuit, as seen here, and calculations carried out as a whole network where nothing but a simple series circuit is left. Conclusion. It is quicker than other methods, it's simple to understand, it's another way to calculate voltages and currents in a simple or complex circuit. Hope you've enjoyed my brief presentation on Thevenin's equivalent circuit and Thevenin's theorem. Thank you.